I'm Ivan Blumenthal, a retired pediatrician. Today I'm going to talk about the history of the clinical thermometer. There were three phases. Firstly, the thermometer had to be developed and then the scale established. Finally, the thermometer needed to be adapted for clinical use. At the beginning of the 1st century, in Alexandria, in ancient Egypt, it was known that heated air expanded and could be used to drive a column of liquid. On the left is a device which was used by Philo to measure the heat of the sun. On the right is an ingenious invention by Hero, in which he demonstrated that heating air with a fire could make the cabinet doors open. For almost 1500 years, little changed until the time of the astronomer Galileo in Padua. On the left is a thermoscope built by Galileo. He described the thermoscope as having a bulb the size of a hen's egg with an 18-inch column the width of straw. Warming the bulb by hand would cause downward displacement of the liquid column. The illustration on the right shows the physics of the thermoscope, whereby the liquid column moves in response to air temperature. What Galileo did not appreciate was the effect of barometric pressure. The barometer was only invented in 1643 after his death. This is a picture of Sanctorius. He was professor of medicine in Padua and a colleague of Galileo. Sanctorius was the first person to demonstrate that humans lose water through the skin. Another first was his attempt to measure body temperature. He used this device. The bulb, which was linked to a glass beaded column containing liquid, was placed in the mouth. He used a scale, of the lowest temperature being melting snow and the highest being that of a burning candle. On the left is a picture of Grand Duke Ferdinand II of Tuscany. He was a friend and patron of Galileo. He was particularly supportive of Galileo when Galileo was charged with heresy by the Catholic Church. Ferdinand II had an obsession with instruments and gadgets. He instructed his instrument maker, Andrea Mariani, to build him a thermometer, which is shown on the right of the slide. This thermometer, which is known as the Florentine thermometer, contained alcohol and is the first sealed thermometer. The thermometer shown in this picture is housed in the Whipple Museum, Cambridge. At that time, the hunt was on to find the most appropriate liquid for a thermometer. Fahrenheit thought mercury was the most suitable, as it has some unique properties and a wide temperature range between its freezing and boiling points. Fahrenheit, who is on the left, made the thermometer shown on the right. The very same thermometer, which has his name engraved on the back, came up for auction at Christie's in London in 2012 and sold for £67,250. There are only two others like it, which are in the Boerhaave Museum in Leiden. Fahrenheit, who was of German ancestry, was born in Danzig, now Gdansk in Poland. When he was 15, his parents died of mushroom poisoning. He moved to Amsterdam, where he came in contact with the Florentine thermometer and developed a lifelong interest in thermometry. He traveled extensively in Europe pursuing his interest. It is thought that he died of mercury poisoning and he is buried in The Hague. Following the invention of the Fahrenheit thermometer in 1714, thermometry entered the next phase. A scale needed to be agreed. Many years earlier, in 1665, independently of each other, three people had suggested that a thermometer scale should have two fixed points, the boiling and freezing points of water. The three scientists were Robert Boyle, Robert Hooke, and Christian Huygens, shown left to right in this picture. The Fahrenheit scale was eventually established in 1724, 10 years after he had invented his thermometer. This is Ole Rømer, the Danish astronomer who first discovered the speed of light. When he was mayor of Copenhagen, Rømer met Fahrenheit and showed him his temperature scale. This served as a blueprint for the Fahrenheit scale. Rømer, in keeping with clocks and some astronomical instruments, had a 60-degree scale, which is shown on the left. Fahrenheit thought that the fractions in Rømer's scale were unwieldy and decided on a much larger scale, which is shown on the right. Originally there were 182 degrees between the freezing and boiling point. When he realized that this would make calculations difficult, he increased the freezing point by 2 degrees so that the difference was 180 degrees. Note the body temperature of 96. The true body temperature was established in 1835 when Antoine Becquerel and Brechet showed that it was 98.6 or 37 degrees centigrade. They used a thermocouple, a type of electronic thermometer invented by Thomas Seebeck in 1821. This is Christin, a French astronomer who invented the centigrade scale in 1743. At that time, he was very much in the shadow of the well-known French astronomer Réaumur, who had already developed an 80-degree scale. When Christin presented his scale to the Academy in Lyon, he claimed to have done his best, but stated that he would not be offended if his scale was not used. Christin's thermometer is also known as the Lyon thermometer. This is an original Lyon thermometer, which is housed in the Museum of Science in London. The French inscription at the top indicates that it is the thermometer of Lyon made by Pierre Casati. On the left is the Swedish astronomer Anders Celsius. He had a short life, dying of tuberculosis in 1742. On the right is a picture of his observatory in Uppsala, Sweden. Celsius developed his scale in 1742. It is known that Celsius had used the thermometer of the French astronomer Joseph Nicolas Delisle. The Delisle scale had a boiling point of 0 and a freezing point of 150. Celsius copied the Delisle scale, but made his freezing point 100. The advantage of such a scale is that in the event of extreme cold, there would be no negative numbers. This is a picture of the original Celsius thermometer, which he used in his observatory. It is housed in the Gustavanium Museum, Uppsala. When you look closely, you can see that the numbers increase as they descend. This is the famous Swedish botanist Carl Linnaeus. Linnaeus needed a thermometer for his greenhouse. At that time, the foremost instrument maker in Sweden was Daniel Ekstrom. In 1743, Linnaeus commissioned Ekstrom to make him a thermometer with the reverse Celsius scale, so that freezing was 0 and boiling 100. This thermometer was completed in 1744. On the way from Stockholm to Uppsala, it was broken. A new thermometer was then made, and it was presented to the University Board in 1745. One of the professors at that presentation was Stromer, Celsius's successor. Shown on the right is a Linnaeus thermometer, but this one was not made by Ekstrom. This slide shows the two scales which were eventually arrived at, centigrade and Fahrenheit. In some languages, degrees centigrade are used to describe certain geometric measurements. So as to avoid confusion, in 1948 it was decided that the centigrade scale should be known as the Celsius scale. Why they chose to bestow this honor on Celsius is not clear. Perhaps because he did have the first centigrade scale, despite it being upside down. Most of the world now uses the Celsius scale, except for America and a handful of other countries. At one time, there were over 30 temperature scales. Some, such as the Kelvin absolute zero scale, are still widely used. I have only talked about scales which are relevant to clinical medicine in this talk. Having achieved the thermometer and its scale, the next phase was clinical use. At that time, Leiden University was a center of excellence in medicine, which attracted physicians from across Europe. The head of the medical department was Herman Boerhaave, a professor with an international reputation. The picture on the right is of Boerhaave, who was also a friend of Fahrenheit. Boerhaave saw the potential of thermometry in medicine, a much better proposition than feeling the warmth of the skin, which was the custom at that time. Convinced of the value of thermometry, he inspired his trainees to take bedside temperature measurements. Some of his best-known trainees in the field were George Martin in Edinburgh and von Swieten and de Haan in Vienna. Despite some very good publications by these physicians, clinical thermometry did not seem to make any inroads into routine medical care. The turning point came in 1870 when a German physician, Karl Wunderlich, published the biggest study of clinical thermometry ever undertaken. This is a picture of Wunderlich, who was based in Leipzig. His magnum opus was published in the journal shown on the left. The English translation followed a year later in 1871. The translation of the title is The Course of Temperature in Disease. Wunderlich studied 25,000 patients and took more than 1 million temperature measurements. Before 1870, it was believed that fever was a disease. Wunderlich demonstrated for the first time that fever is not a disease but merely a symptom of disease. He also showed that body temperature is not constant but has a diurnal rhythm, which means a daily pattern. I will demonstrate this in the next slide. Plotted in this graph is time of day on the x-axis and body temperature on the y-axis. The vertical lines show the temperature range at each time, and the blocks are mean readings. By looking at the blocks, you will notice that body temperature is lowest at about 6 a.m. and rises throughout the day to reach its zenith between 4 and 6 p.m. The difference between the lowest and highest points being almost a half a degree Celsius. This is one of the thermometers used by Wunderlich. It was a foot long, approximately 30 centimeters. The bulb was placed in the axilla, which is the armpit, for 20 minutes before it was read. This thermometer is housed in the Mutter Museum in Philadelphia. On the left is Sir William Aitken, an army pathologist. He commissioned a very eminent instrument maker, a Mr. Louis Casella, to make his thermometers. On the right are his thermometers, together with a wooden storage box and instructions. The curved thermometer was placed in the axilla and read while in the axilla. The straight thermometer had a novel feature. By creating a constriction above the bulb, the mercury column remained in place after the thermometer was removed from the axilla. For the next reading, the thermometer was reset by shaking down the mercury. This innovation is still used in modern thermometers. These Aitken thermometers are housed in the London Science Museum. The inventor of the short or pocket clinical thermometer was Thomas Allbutt, who is shown on the right. He was professor of medicine at Leeds General Infirmary. He asked Mr. Casella to make his thermometers, but he refused. Allbutt then used a local Leeds company, Harvey Reynolds. In 1867, Allbutt described his thermometer in the Lancet as scarcely 6 inches in length and not much thicker than a stout pencil. These thermometers were exported around the world. This Allbutt thermometer is housed in the Thackeray Museum in Leeds. This is a photograph of Luigi Peroni, a glass blower at Hatton Garden, London. He accidentally discovered that a triangular-shaped thermometer would magnify the mercury column. This magnification effect became known as the lens front thermometer. Peroni patented his invention and later sold on the patent. A big advantage of a triangular thermometer is it is less likely to roll, which would reduce breakage. This is a Peroni lens front thermometer with his name engraved on the back. A view of the back can be seen on the left side of the slide. This is a modern-day lens front thermometer. Note the clarity of the mercury column and graduations. Mercury is a poison. There have been a number of environmental disasters caused by mercury. One of the worst occurring at Minamata Bay, Japan, about 65 years ago. Seawater became polluted with mercury, resulting in brain-damaged babies when pregnant women ate the fish. As a consequence of these catastrophes, both environmental and health agencies began to question whether mercury-containing products should be used when safe alternatives exist. I and many others wrote papers questioning the use of mercury thermometers. On the right is a reference to a discussion paper I wrote for the Journal of the Royal Society of Medicine in 1992. In 2009, the European Union banned the supply and distribution of mercury thermometers. They are currently banned in 13 states in the USA, and from January 2026 will be banned in China. This slide shows another example of mercury poisoning, which gives rise to the expression "as mad as a hatter." Mercury was used in making the felt for hats. In the illustration is the Mad Hatter at the tea party in Alice in Wonderland. Note his big felt hat. When Lewis Carroll wrote the book in 1865, he was probably well aware of the mental health problems hatters faced. It was only in 1941 that mercury was banned from the hat industry in America. The 3 categories of safe and accurate alternative thermometers are shown on this slide. I will demonstrate these in my upcoming slides. This battery-operated electronic thermometer is cheap to purchase and is ideal for home use. In 1821, Humphrey Davy showed that the resistance of a metal to a current will vary with temperature. The first resistance thermometer was invented by Sir William Siemens in 1871 using a copper wire. In this modern-day resistance thermometer, the battery generates a current and the resistance is computed into a digital temperature reading. The chemical dot thermometer was developed by Weinstein and was first used in hospitals in the 1970s. With the onset of HIV in the 80s, it became popular as a single-use thermometer. At that time, some hospitals in England used it as their sole thermometer. The dots consist of 2 organic chemicals. They are formulated in such a way so that at different temperatures they liquefy, causing dye release and a blue color. The last blue dot represents the temperature. Some dot thermometers of this type use liquid crystals, which also change color at different temperatures. This is an infrared thermometer. Infrared radiation was discovered by William Herschel in 1800. He called the invisible rays radiant heat. During the 1930s and 40s, especially during the war years, great advances were made in infrared technology. Such technology enables temperature to be measured without contact. Body temperature is controlled by the part of the brain known as the hypothalamus. The hypothalamus and the eardrum have a common blood supply. It therefore follows that eardrum temperature would be a good reflection of body temperature. The ear thermometer uses infrared technology to remotely measure eardrum temperature as shown in this picture. The ear thermometer was invented in 1964 and it went into commercial production in 1968. With the passage of time, it has become much cheaper. It is now the #1 thermometer used by British hospitals. The main advantage is its speed. You press a button and get the result instantly. On the left is Theodore Benzinger. On the right is the headline of his obituary in the New York Times in 1999. Benzinger was a brilliant aviation scientist who worked directly for Hermann Goering and the Luftwaffe during the Second World War. At the end of the war, he was arrested and was expected to stand trial in Nuremberg. That never happened. As part of Operation Paperclip, he was relocated to the American naval base at Bethesda, Maryland. It was there that he invented the ear thermometer in 1964. Surprisingly, in the obituary, Benzinger's Nazi past and Operation Paperclip were never mentioned. In this short talk, I've traced the origin of the thermometer from the 1st to the 21st century. I've discussed temperature scales and have shown how the clinical thermometer evolved. This brings my talk to a conclusion. I hope that you found it interesting.